Alright folks, in this video we are going to take a look at stoichiometry. Okay, we're going to take a look about what it is, what does it tell us, how do we use it, what kind of problems are we going to solve. Okay, so you're going to need this document because you're going to be recording some notes by filling in the blanks. You are also going to need your mole map because we're going to use our mole map to solve our problems. Okay, so let's first start out by looking at what stoichiometry is and what does it tell us. Okay, so stoichiometry is a quantitative study dealing with relationships between the amounts of reactants and products in a chemical reaction. Okay, keyword here being quantitative, so we're going to be dealing with numbers. Okay, and we're going to be taking a look at reactants and products. Okay, two different species in a chemical reaction. Okay, the word stoichiometry comes from the Greek words stoichion, which meant element, and metron, which means measure. So we're measuring elements. Okay, stoichiometry is based on chemical equations and the law of conservation of matter. That means that matter can neither be created nor destroyed in ordinary chemical or physical means. Another way to say it is that the mass of the reactants equals the mass of the products. By using this concept and this idea, we can take a starting amount. So if we know the amount of one substance in a reaction, you can then determine the amounts of everything else. Okay? We are going to be looking at two substances specifically. Okay? There might be multiple in the equation, but we are going to be taking two of them. All stoichiometry problems are solved by converting the given into the units that you are looking for. So that could be grams, liters, particles, moles, etc. And we do that by using dimensional analysis. Okay, we're going to be starting with one thing and then ending up with something else. Okay, we could, for example, start with grams and end with particles. We could start with grams and end with moles. For the most part, you're going to start with grams of one substance and end with grams of the other. Okay, so go ahead and make sure you have those notes written down for our first little section on what is stoichiometry. So let's go to our second part now. What is the role of a mole ratio in reaction stoichiometry problems? So the mole ratio is a conversion factor that relates the number of moles of any two substances involved in a chemical reaction. Okay, so a ratio involves two different things and they're going to relate the moles. It is obtained directly from the balanced chemical equation. So for all of these stoichiometry problems, you're going to be given a chemical equation. Usually it will be balanced for you already, but if it wasn't, you would have to do it yourself. And then the moles in a chemical equation are going to be used to create this mole ratio. Okay, where do we get the mole ratio? Where do we get the moles? Well, the coefficients, which hopefully you remember are the numbers that go at the beginning of the equation, they help to satisfy the law of conservation of matter, and they represent the relative number of moles of reactants and products. Okay, so when you have a balanced equation, that number at the beginning of the substance is the coefficient and it represents the moles. So let's interpret the following balanced equation. We have 2 Al2O3 yields 4 Al plus 3O2. Another way to say this is that 2 moles of Al2O3 aluminum oxide, they decompose to produce 4 moles of aluminum and 3 moles of O2 or oxygen gas. Right? So the coefficients represent the moles. 2 moles decompose into 4 moles of aluminum and 3 moles of oxygen. From these numbers, we can get a mole ratio. Now remember, a mole ratio just involves 2 substances. So, for example, number 1 asks, what is the mole ratio between aluminum oxide and aluminum? Right, well, aluminum oxide, the Al2O3 has a 2 in front. So I'm going to put 2 moles. And the way we create a mole ratio is a division sign. Okay? It's always going to be like a conversion. 2 moles of aluminum oxide is equal or going to produce 4 moles of aluminum. Okay, so the mole ratio between aluminum oxide and aluminum is 2/4. And that comes directly from the balanced equation. Okay, let's look at the second example. What is the mole ratio between aluminum and oxygen? Well, in this case, aluminum has a 4 in front as its coefficient, so 4 moles. Then we have our division symbol, which is going to be our conversion factor. And oxygen has 3, so we're going to put a 3 mole. So this mole ratio would be 4/3. And last but not least, we have our third example. What is the mole ratio between aluminum oxide and oxygen? Okay, well, aluminum oxide, just like the first example, is a 2 mole. And it's going to be 2 moles over oxygen, which is 3 moles. So as you can see, it doesn't matter what substances we look at, the mole ratio will change depending upon the balanced chemical equation. So go ahead and write those numbers down. And now we're going to put all of this together, and I'm going to show you how we're going to do stoichiometry problems. Okay, so we're going to go to the second page. So how do we solve stoichiometry problems? Let's first look at our 3 steps, and then we'll go into 3 different examples, one of which is already done, and then the next 2 we will do together. So step 1 is to figure out what you are given. So in the problem, every example, you're going to be given a number. This is going to be the A on your mole map. This is the thing you are starting with. What I want you to do to help you out is to highlight it green. Okay? Hopefully you know there's the highlighter up at the top. Okay, you can highlight different colors. I say pick green, so you know that is where you're going to start with. Step number 2 is determine the unknown. So this is what you're looking for. In each problem, there's going to be some sort of unknown. It might say how many or how much. This is going to be the B on your mole map, the right-hand side of your mole map that we added. Okay? What I want you to do in this case is to highlight it yellow. Okay, so green for the start, and then the yellow is where you're going. Okay? Once you've identified that, you're going to use your mole map to convert from one unit to the next. You are always going to start with your given information and make sure your answer is what you are looking for. So if it says how many grams, make sure your final answer ends in grams. So what I want to do with you all is look at the first example that is already completed for you. And I'm going to take you through step by step and talk about what is going on and how we do the problem. So example 1 says how many grams of hydrogen gas are produced from the reaction of 30 grams of zinc with an excess of hydrochloric acid. So we are given the balanced equation. It is already balanced. So now we can start with step 1, which is to identify our starting material. And the way you identify your starting material is look for the number. Okay? The number in the problem is always going to be your starting material. So if it says we are starting with 30 grams of zinc. Okay, so I highlighted that green, and then I went into my balanced equation and also highlighted it green. So that is my starting material. Step 2 said to find your B. Find where you're going to end and highlight it yellow. You are going to find this in the question. How many or how much? Well, it says how many grams of hydrogen gas are produced. So that is my unknown. That is what I need to figure out. So I am highlighting that whole thing in yellow, including whatever chemical I'm looking for. And then I found hydrogen gas and highlighted it yellow as well. Now, once you've identified the first and ending materials, those are the only two things you are concerned about. Okay? The things that I highlighted are what I'm going to focus on. The non-highlighted chemicals in the balanced equation, you ignore. So this is where we are going to use our mole map. Okay? You need to get from one side of your mole map, the left-hand side, to the right-hand side of your mole map. Okay, you're going to start somewhere in A and end somewhere in B based upon what the question is asking. So if we look at the problem, it says we're given 30 grams. So I write that down first. You always start with your given. Well, if I look at my mole map, I'm in mass small A, which is all the way on the left-hand side. Okay? So I'm going to start in mass small A, which is where I wrote down. Now the question asked how many grams of hydrogen gas. Well, grams is another example of mass, and that's your B. That is your unknown. That is what you are looking for. So this is over here on the right-hand side of your mole map in mass mol on the B side. So if we just take a look at our mole map, we have to get from mass mol A on the far left all the way to mass mol B on the right-hand side of our mole map. Now there is no direct route. There is no way to get from one mass mol to the other mass mol. Okay? Remember, these are two different towns, two different areas. There's no direct route. But there is a path that we can take. It just takes multiple steps. We can go, as an overview, start in mass mol A. We follow the arrow to get to mole town A. Once we are in one mole town, we can get to the other mole town through this mole ratio bridge in the middle. And then once I'm in mole town B, I can follow this arrow and get to my other mass mol. Okay, so let me repeat that. We're going to start mass small A all the way to the left. Our first step is to get to mole town A. Our second step is to get from mole town A to mole town B using our mole ratio, and then take this one final path up to get to mass small B. So this is why it's so important to have this mole map, because you're always going to have access to it. You're always going to be able to look at it. Now let's take a look at how the math works out. Okay, I've already labeled each step for you, so pay attention to this. Always come back to this example problem. So like I said, we started with 30 grams of zinc. That's my starting material. In order to convert mass to moles, I have to use a molar mass conversion to get from mass small A to mole town A. So in this case, I'm going to do, according to my mole map, it says put molar mass on top 1 mole on the bottom. On this side, I'm still at zinc. So I'm going to use the molar mass of zinc. I looked at a periodic table, and it was 65.38 grams. So that number goes in the bottom. So as of right now, I am in Moletown. Okay, that was my first conversion. You had lots of practice doing that, so hopefully that was review for you. The next step is to go from one Moletown to the other Moletown, and this is where it says use a mole ratio from the balanced equation to get from Moletown A to Moletown B. We have to look at the balanced equation and we have to look at the coefficients. It is always, on our mole map, moles of B divided by moles of A. So B over A. Okay, well, B is our yellow. So that goes on top. What coefficient is in front of H? That would be a 1. So that is why I have 1 mole on top. A is on the bottom, which is my green, what I'm starting with. Well, what number is in front of my green zinc here? That would also be a 1. Okay, remember, if there's no number listed, it's a 1. So the mole ratio is a 1-to-1 ratio. For every 1 mole of zinc, you produce 1 mole of hydrogen. So, after this step, I am in Moletown B. Now, if we remember, our problem said how many grams. So that means I have to get to mass mole. So I have to go from Moletown B up to mass mole. And it says to do molar mass divided by 1 mole. So we need to use that molar mass conversion to get from Moletown B to mass mole. And we're going to do hydrogen. Remember, it says H2. So that means I take whatever is hydrogen's molar mass on the periodic table and multiply it by 2. That gets us to 2.02 grams. So 3 steps is the maximum number of steps you are going to do. Once you do all of the math, you're going to end at mass mole. So you started in one mass mole and ended in the other mass mole. Hopefully you remember that to do the math now, once you've set it up, you multiply every number that is on top and divide by every number on the bottom. I want you to remember to also ignore the ones. If it's a 1, don't worry about it. So in my calculator, I would take 30 divided by 65.38 and multiply it by 2.02. When I do that and I put in my calculator, I would get 0.93 grams. The whole purpose and the whole point of doing stoichiometry is to figure out if I start with something, a certain amount, how much product can I make? And that comes from the balanced chemical equation. So now we're bringing in everything we've learned about the mole and balanced equations and law of conservation of matter, and we're bringing it all together. Okay? Really, really focus and come back to this first example if you are having trouble. Because many, many, many of the problems that you're going to be doing look like this. Okay, why don't we do example 2 together? So example 2 says how many grams of potassium bromide are produced when 118.54 grams of potassium phosphate reacts with iron 3 bromide. In order to do this problem, we're going to go back to the top. And it says step 1, figure out what you are given. This is the A on your mole map and highlight it green. So the given is always going to be your number. So in this case, we're given 118.54 grams of potassium phosphate, and I'm going to highlight it green. Now, potassium phosphate is K3PO4. So I'm also going to highlight that, make sure I get everything. Okay, all the subscripts. Okay, so you have to know your naming. Okay, you have to be able to identify which substance are you starting with. Step 2, if we go back to the top, said determine the unknown. What are you looking for? This is the B on your mole map, and we're going to highlight it yellow. So it says how many grams of potassium bromide. That's what I'm looking for. I don't know how much. I'm going to highlight it yellow. And potassium bromide is KBr. Now, I'm only going to highlight the formula. Okay, I'm not going to highlight the coefficient. I'll come back to that in a little bit. So now I've highlighted what I'm starting with. That is in green. That is my A. That's my left side of my mole map. I've also highlighted my B. What am I looking for? What is my unknown? That is highlighted in yellow. So what you can do to do this problem is you can copy this setup, because many of the problems are going to be looking like this. If you don't want to do what I'm about to do, is I'm going to insert an equation. Okay, so if you'd like to follow along, up at the top you would have insert, and then you have an equation button to add. Okay, so I'm going to go through how to do this problem step by step. Okay, you should be typing this in as we go along, or maybe writing it down so you can do this on your own. So you always start with your given. Okay, step 3 says use your mole map to convert from one unit to the next. Always start with your given. So what we were given was 118.54 grams. That is my given, and then I'm going to have my first conversion factor. Okay, so I'm starting with a mass and I'm ending with a mass. So it's the same setup as the first problem, excuse me. Okay, so I'm in mass small. I have to get to my other mass small. The first step is to go from mass small to mole town, and it says 1 mole on top, molar mass on the bottom. Okay? If you want to insert a division symbol when you are in the equation editor, you go to the fraction, and you would get something like that. Okay? I put 1 mole on top, and I need my molar mass. Okay? Well, I'm in potassium phosphate, K3PO4. Okay, you would go to the periodic table, you would do 3 Ks, 1 P, 4 Os, get those numbers. I already did that for you, and it is 212.27 grams. Okay, we can see that the units are gonna cancel. We want that to happen. Okay, that is my first conversion. Okay, getting to moles. You have to, whenever you do 2 different substances, you have to convert to moles first. Because the next step is to do a mole ratio, right? We look at the top, use a mole ratio, and that comes from the balanced equation, right? Moles of B divided by moles of A, if we follow our arrow from moletown A to moletown B. So this is where the coefficient comes into play. Okay, you never use the coefficient for the molar mass. You only use the coefficients in the mole ratio. So moles of B, that is my yellow. That is where I'm going. That is my unknown. So I'm going to insert another fraction symbol. Well, where I'm going is yellow. And what do I have in front of the KBr, the potassium bromide? I have a 3. So I need to put 3 moles on top. And then on the bottom is my A. That's my green. So I look at my K3PO4 and what number is in front? Well, there's nothing there, which indicates that it's a 1. So we have a 3-to-1 ratio. That 3-to-1 ratio comes from the balanced chemical equation from the coefficients. that was my mole ratio. That was my next step. And once I'm in mole town B on the right-hand side, I want to get to mass mole because, again, the problem said how many grams. So I'm going to go up to the top, and it says molar mass divided by 1 mole. So again, I'm going to insert my conversion, my fraction. I know 1 mole needs to go on the bottom, and then I need the molar mass of whatever my B is. That is my yellow. That is my KBR. Okay? Do not multiply it by 3. You already did that in the step where you did the molar mass. So I looked up the molar mass, and it is 119.00 grams for KBr, potassium bromide. So we started with grams, and we're going to end in grams. Everything else cancels out. Once we do that, we can do the math. So we would do, in our calculator, 118.54 divided by 212.27 times 3 times 119.00. When you put that in your calculator, you should get 199.36 grams. So that is how many grams of potassium bromide that are produced when 118.54 grams of potassium phosphate reacts. And I'm going to copy my answer box, and I'm going to insert it here so we know exactly what my answer is. Again, we can see there's a maximum of 3 steps, okay, 3 different conversions that need to be included, okay? If you do more than 3, you know you did something wrong, okay? Also, remember to highlight. Highlight green what you're starting with, yellow what you are ending with, okay? It'll make your life so much easier if you highlight it. Okay, last but not least, I want to do example 3. Again, we're going to do this together. Example 3 says, what mass of sodium is required to produce 25 grams of sodium chloride? Okay, do you remember what step number 1 is? Okay, if you don't remember, check the top. Step 1 is to highlight in green what you are given. What are you starting with? That is the number, 25 grams of sodium chloride. Okay, sodium chloride, do you remember what the chemical formula is? That would be NaCl. And again, I'm going to highlight that green. Then it says, what mass of sodium is required? So do you remember what step number 2 is? Identify the unknown. What are you trying to find? Well, I'm trying to find what mass of sodium is required. And you're going to highlight that in yellow. Okay, sodium, that's our Na. And again, I'm going to highlight that yellow too in my formula. So, once I figured out my 2 materials, my starting and my ending, I ignore the other thing that's not listed, but I want to point out something interesting with this problem. Where we are starting is actually a product, but that is still our A on our mole map. So even though we're starting on the right-hand side of our equation, you're still going to start on the left side of your mole map. You always, always, always go from left to right on your mole map. When we're doing stoichiometry problems, although usually they're just like the first 2, sometimes we can go backwards. In this case, we know how much we want to produce, but we need to figure out how much do we start with. Okay, so I'm going to, again, insert my equation. and I always write down my given value, 25 grams. I know I'm going to have to do a conversion. That's going to be a fraction. We'll insert there. Again, I'm starting in mass because I'm given 25 grams, and I need to end with mass. So I'm going again, mass small a to mass small b. So the setup is still the same as examples 1 and 2. Okay? I need to put 1 mole on top according to my mole map and the molar mass of sodium chloride. That is my green. That is what I'm starting with. So I looked at my periodic table and I found Na and Cl, added it together, and it was 58.44 grams. I'm going to do my next step. Okay, once I've converted to moles, if you follow the mole map, the next step is to do a mole ratio. And I always do a mole ratio with moles of B on top and moles of A on the bottom. Well, the B is where I'm going. That is my yellow. According to my balanced equation, it is a 2. So I put 2 moles on top. A is on the bottom, and it's where I'm coming from. It is also a 2. So it is a 2 to 2 ratio. After I do my mole ratio from the balanced equation, I'm in mole town B. So now I need to go from mole town B to mass mol B. And in order to do that, I'm going to insert one more setup conversion with 1 mole on the bottom. And again, this is what I'm looking for, the mass of sodium. So I need to find the molar mass of sodium. Molar mass of Na is 22.99 grams. So once I do that, I am now ready to input everything into my calculator. I would do 25 divided by 58.44 times 2 divided by 2 times 22.99, and I would get 9.83 grams. So I'm going to insert a box around my answer. What this problem states is that in order to make 25 grams of sodium chloride my product, I need to start with exactly 9.83 grams of sodium. If I started with more, then I would get more sodium chloride at the end. And if I started with less, then I would obviously get less of my product that I want. So the whole point of stoichiometry is to take 2 chemical substances in a balanced equation and convert from one to the other. And in order to do that, you're going to have to use your mole map.